All right, 7.1a. We do these mods in kind of a funky order. We do mod 6 and then we follow it with mod 7. And then we go to mod 5. So mod 5 really brings it all together. So this is solving by factoring. So things aren't going to get too crazy today, but they will get crazy. So obviously factoring is in the instructions, so we're going to be doing more factoring. So if you didn't dislike it enough already, there's more time for you to dislike it. There's just one more step. So let's see, hang on. Yeah, let's go ahead and start with our first example. So what's kind of funky about this one? There's an equal sign. Absolutely, the equal sign is very significant. What else is kind of funky about it? There's x's on both sides, which means what? It's not in standard form. Okay? So if I need to put this into standard form, and I want everything on the same side of the equal sign, what do I need to do? Subtract 19x. Now 19x doesn't have a like term over here, does it? So it's going to cancel out there, and I have 0 equals 6x squared minus 19x minus 7. Yes? Yeah. Okay. What kind of factoring would I use here? I'd use the snowflake or the super x, right? What would go on top? 6 times negative 7, which is negative 42. And on the bottom, what are two numbers that multiply to get negative 14? I'm sorry, negative 42, and add to get negative 19? Negative 21 and positive 2. Okay. What goes on the top? 6x and, all right, 6x over negative 21, what does that reduce to? 2x over negative 7, and this one? 3x over 1. So one parentheses there, one parentheses there. I have 0 equals 2x minus 7 and 3x plus 1. Is everyone okay with that? Now, because it has the equal 0, that tells me I have to go one more step. Does anyone remember from IM2 what that extra step is? No. I have to take each of these and set them equal to 0. Remember this? So it's just adding that extra step. So over here I'm going to add 7. That gives me 2x equals 7. Divide by 2. I do not want decimals. Okay? My general rule is the only time you're allowed to give me a decimal answer is if there was a decimal in the problem to begin with. If not, I just want you to leave it as a fraction as long as it's reduced. Can 7 over 2 reduce any further? No. So we're just going to leave it as 7 over 2. Okay? Over here I would subtract 1. 3x equals negative 1. Divide by 3, and x equals negative 1/3. Why did I get fractions there? Because they couldn't evenly divide. What kind of a hint from up here would tell me that I was going to get fractions in my answer? When there is a coefficient of x, most likely I'm going to have fraction answers. Okay? Now, how many parentheses did I have?
4.
I had 2 parentheses. How many answers did I have? 1, 2, 1, 2, right?
Yeah.
So? Okay, that's going to be important in just a minute. Let's see. Actually, hang on. Let me write this here. Going back to day 1. Remember how to find the degree of a polynomial?
Nope.
When you're looking at it in standard form, or actually in the beginning, what's the largest coefficient? I'm sorry, not coefficient. What's the largest exponent?
2.
Largest exponent is 2. That means we have a degree 2 polynomial. The number of solutions we got. How many solutions do we get?
2.
2. I'm going to give those solutions a couple other names. Solutions can also be called roots. And they can also be called zeros. And most frequently I will be calling them zeros. Okay. So? All right. Example number 2. Three x to the 4th minus 2x cubed minus 15x squared plus 10x equals 0. All right. So, what's the degree here?
4.
Is a 4. How many solutions or zeros or roots do you think we're going to find?
4.
Well, if I had a degree 2 and I found 2, do you think I'm going to find 4 here since it's a degree 4?
Yeah.
Yeah. That's actually something really important. Knowing the degree is the same as the number of solutions. It's actually called the fundamental theorem of algebra. It's that important in algebra. I'll define it a little more in a minute. So I'm going to be looking for 4 answers. Is there anything in common with all of those terms that I can take out? I can take out an x, okay? What's left inside? 3x cubed minus 2x squared minus 15x plus 10 equals 0. Okay? What kind of factoring do I have going on here? Grouping. So I'm going to cut that in half. What do these two have in common? X squared. What's left inside? 3x minus 2. Bring down the minus sign. Now, on the test yesterday, hang on. So what do these two have in common here, though? 5. Oops, I shouldn't have started my parentheses. 5. Negative 5 times what is negative 15x? Negative 5 times what is positive 10? So let's see. I have x squared minus 5, and I have 3x minus 2, and I have an x out in front, right? And then the equals 0. Because there were 4 x's, or it was x to the 4th to begin with. I should still see x squared x, something that is equivalent to x to the 4th. Yeah? All right, so I'm looking for 4 answers. Well, this answer to me is the easiest one to find. Right? Set 3x minus 2 equal to 0. Add 2. So I get 3x equals 2. Divide by 3. And x equals 2/3. That's one of my how many answers? 4. So I have how many more? 3. There's actually a root that's easier, or a 0 that's easier to find. When you have an x out in front. By the way, that's that x, not... all I need to do is set x equal to 0, and there's no solving, but there's another root. There's another 0. So I have 2. Where do you think I'm going to get my last 2? Where the x squared is. See the degree 2? I'm going to get 2 answers from there. So if I set x squared minus 5 equal to 0, how am I going to get x by itself? Add 5, right? That gives me x squared equals 5. How do I get x by itself now? Take the square root. Now, when I take the square root of something, what do I have to remember? Positive and negative. Right? Because the square root of 9 is not just 3. It's 3 and negative 3. Does that make sense? So how many answers are right there? 2. Positive radical 5 and negative radical 5. So my degree was 4. I was looking for 4 solutions, and I have 1, 2, 3, 4. Yay, I'm done. Okay, where's the fourth one? This is 2 solutions. Remember, it's positive radical 5 and negative radical 5. Okay, so here's 1, here's 2 and 3, and there's 4. So, going back to discuss this idea right here, the degree and the number of solutions being the same. That is known as the fundamental theorem of algebra. Sounds kind of important just by that name, doesn't it? That it's a fundamental of algebra. Says, now I could give you the textbook definition right here, or I could give you the Franken definition. Which is that? The degree is equal to the number of zeros. By the way, zeros, solutions, roots, those are all terms for the same thing. So as you're going through your homework, those are the only 2 examples I have for you today, because I guess we're starting out easy. We're not getting too crazy yet. But we're going to get to ones that maybe are a 5th degree, and we're going to have to figure out what to do with them to get all 5 answers. Now let me explain really quickly why these answers are significant, because remember how I told you when we started factoring that we're learning the skills, but we're going to actually put it all together to see what it does for us later. All of these things we have to find by factoring here. And when we get to graphing, these are actually my x-intercepts. So if I were to graph this equation right here, it crosses the x-axis at 0, at positive radical 5, whatever that decimal is, at negative radical 5, and at 2/3. So somehow it's going to zigzag back and forth and cross the x-axis at those 4 points. Okay, so that's why we need to get good at this, because we're going to get to graphing and have to find those x-intercepts to help us graph. Okay? All right, so your homework is on Google Classroom. Happy studying.